Hydrogen, the most abundant element in the universe, a clean fuel source, and a potential answer to our energy woes. Burning hydrogen produces only water vapor, making it a pollution-free energy carrier. For decades, scientists have touted hydrogen as the fuel of the future, a key to unlocking a sustainable energy future. Yet a significant hurdle remains: efficient and cost-effective hydrogen production. Traditional hydrogen production methods like steam methane reforming rely heavily on fossil fuels and release harmful greenhouse gases. Electrolysis, while cleaner, often demands high energy input, diminishing its overall sustainability. This efficiency bottleneck has hampered the widespread adoption of hydrogen as a mainstream energy source. We need a revolutionary approach, a technology that can unlock hydrogen's true potential and usher in a new era of clean energy abundance. MEQ semiconductors represent a paradigm shift in material science and energy production. They operate on the principles of quantum mechanics, where the familiar rules of classical physics give way to the astonishing world of the ultra-small. At these minuscule scales, electrons, the fundamental particles of electricity, behave in unexpected ways, exhibiting both wave-like and particle-like properties. MEQ semiconductors are meticulously engineered to exploit these unique quantum phenomena. Their structure incorporates fractal geometry, a mathematical concept describing infinitely self-similar patterns found throughout nature, from snowflakes to coastlines. This intricate design, etched at the nanoscale, creates a vast internal surface area within the semiconductor. This expansive surface area becomes a key player in the hydrogen splitting process. But the innovation doesn't stop there. MEQ semiconductors also leverage subtle gravitational effects at the nanoscale. While gravity is often perceived as a weak force, it exerts a significant influence at these minute dimensions, further enhancing the semiconductor's efficiency. Together, quantum mechanics, fractal geometry, and nanoscale gravitational effects converge within MEQ semiconductors, creating an environment where hydrogen production is not only efficient but also remarkably cost-effective. This powerful synergy paves the way for a future where clean, sustainable hydrogen fuel becomes a reality for all. To truly grasp the revolutionary nature of MEQ technology, we must delve deeper into the intriguing interplay of quantum mechanics, fractal geometry, and nanoscale gravity. Imagine a snowflake, its delicate structure an example of fractal geometry. Now picture this intricate pattern etched onto the surface of a semiconductor, creating an incredibly large surface area within a confined space. This vast surface area, a hallmark of MEQ semiconductors, becomes a stage for the quantum dance of electrons. In the quantum realm, electrons don't behave like tiny balls, but rather like waves, their movements governed by probability rather than fixed paths. The fractal geometry of MEQ semiconductors manipulates these electron waves, enhancing their energy levels and making them more reactive. Now, consider the often overlooked force of gravity. While seemingly insignificant at the macroscopic level, gravity becomes a key player in the nanoscale world of MEQ semiconductors. The increased surface area, combined with precisely engineered nanoscale features, amplifies gravitational effects, further influencing electron behavior and optimizing their interaction with water molecules. This intricate interplay of quantum mechanics, fractal geometry, and nanoscale gravity is the secret sauce of MEQ technology. It's a testament to the power of harnessing the fundamental forces of the universe to solve our most pressing challenges, paving the way for a cleaner, more sustainable future. At the heart of MEQ technology lies the elegant process of water splitting. Imagine sunlight striking the surface of an MEQ semiconductor, its energy absorbed by the material. This energy excites the electrons within the semiconductor, propelling them to higher energy levels. These energized electrons are now primed for action, ready to facilitate the breakdown of water molecules. Water, H2O, consists of two hydrogen atoms bonded to an oxygen atom. The energized electrons within the MEQ semiconductor interact with these water molecules, weakening the bonds holding them together. This process, known as electrolysis, liberates the hydrogen atoms from their oxygen counterparts. The fractal geometry of the MEQ semiconductor plays a crucial role in this process. The vast surface area, dotted with precisely engineered nanoscale features, acts as a catalyst, accelerating the rate at which water molecules come into contact with energized electrons. This enhanced interaction boosts the efficiency of the water splitting process, maximizing hydrogen production. As the hydrogen atoms are freed from their oxygen bonds, they combine to form diatomic hydrogen gas, H2, a clean, energy-rich fuel. Meanwhile, the oxygen atoms also pair up, forming breathable oxygen gas, O2, as a byproduct. The entire process is clean, efficient, and powered by renewable energy, highlighting the immense potential of MEQ technology in creating a sustainable energy future. Traditional hydrogen production methods, often reliant on fossil fuels, have long been plagued by inefficiency, hindering the widespread adoption of hydrogen as a clean energy carrier. MEQ Semiconductors, however, offer a beacon of hope, their unique properties ushering in an era of unprecedented efficiency in hydrogen production. The key to this remarkable efficiency lies in the synergistic interplay of quantum mechanics, fractal geometry, and nanoscale gravity within MEQ semiconductors. This trifecta of scientific principles creates an environment where energy conversion is optimized at the atomic level. The fractal structure, with its vast surface area, maximizes the interaction between energized electrons and water molecules, accelerating the water splitting process. Furthermore, the precise engineering of nanoscale features within the semiconductor enhances the capture and utilization of solar energy. This targeted energy absorption ensures that a greater proportion of sunlight is converted into usable energy for water splitting, minimizing energy waste and boosting overall efficiency. This remarkable efficiency translates into a lower energy input requirement for hydrogen production, making MEQ technology a game-changer in the quest for sustainable energy solutions. The ability to produce clean hydrogen fuel using minimal energy input brings us closer to a future where renewable energy sources power our world. The groundbreaking potential of MEQ semiconductors extends far beyond the confines of research laboratories. Their unique properties hold immense promise for real-world applications, poised to revolutionize various sectors, from transportation to industrial manufacturing. Imagine a future where cars, buses, and trucks are powered by hydrogen fuel cells, their only emission clean water vapor. MEQ semiconductors can make this vision a reality by enabling the efficient production of hydrogen fuel at refueling stations, reducing our reliance on fossil fuels, and combating climate change. In the industrial sector, MEQ technology can decarbonize energy-intensive processes. From steel and cement production to ammonia synthesis, MEQ-generated hydrogen can replace fossil fuels, significantly reducing greenhouse gas emissions and paving the way for a more sustainable industrial landscape. Moreover, MEQ semiconductors can be integrated into off-grid energy solutions, providing clean and reliable power to remote communities and developing nations. Imagine solar-powered MEQ systems generating hydrogen fuel for electricity generation, irrigation, and other essential needs, empowering communities and fostering sustainable development. The possibilities are as vast as our imagination, as MEQ technology unlocks a future where clean, abundant energy is accessible to all. The advent of MEQ semiconductor technology heralds a paradigm shift in the global energy landscape, offering a tantalizing glimpse into a future fueled by clean, abundant hydrogen. Imagine a world where energy poverty becomes a relic of the past, replaced by a future where every nation, every community, has access to sustainable and affordable energy. With MEQ technology, vast solar and wind farms can be transformed into green hydrogen production hubs. The intermittent nature of renewable energy sources, once a challenge, becomes an opportunity. Excess solar or wind energy can be harnessed to split water, generating hydrogen fuel that can be stored and utilized on demand. This stored hydrogen serves as a clean energy reserve, ensuring a continuous and reliable power supply, even when the sun isn't shining or the wind isn't blowing. This transformative capability of MEQ technology paves the way for a truly sustainable energy future, one where we are no longer beholden to fossil fuels. The implications extend far beyond energy independence. A world powered by MEQ-generated hydrogen means a significant reduction in greenhouse gas emissions, mitigating the effects of climate change and safeguarding the planet for generations to come. It's a future where economic growth and environmental stewardship go hand in hand, driven by the transformative power of MEQ technology. The widespread adoption of MEQ semiconductor technology has the potential to reshape global geopolitics and redefine economic power structures. As nations transition away from fossil fuels and embrace clean hydrogen, dependencies on traditional energy exporters will diminish, leading to a more balanced geopolitical landscape. Countries with abundant renewable energy resources, previously sidelined in the global energy market, will emerge as key players. Vast solar farms in deserts or wind farms in coastal regions will become strategic assets, enabling nations to become energy self-sufficient and even export clean hydrogen to global markets. This shift in energy dynamics will foster greater cooperation and interdependence among nations. The need to establish international hydrogen transportation and distribution networks will encourage collaboration and innovation, fostering a more interconnected and prosperous world. Moreover, the MEQ revolution will spark economic growth and job creation across various sectors. From manufacturing and installation of MEQ systems to research and development of next-generation hydrogen technologies, the opportunities are vast and far-reaching. The transition to a hydrogen-based economy will revitalize industries, create new markets, and usher in an era of sustainable prosperity for all.